Visualizing databases. Elijah Meeks has produced a series of experiments depicting databases in diverse styles. Here we have a visual that maps out the top contributors to the catalog of life and their associated species, references, and databases. It's just a lovely piece of work. Again, another visualization that really walks the line between art and information. Elijah tells us that, while it could be argued that all databases can be devolved into graph databases, and such all databases are graphs and therefore networks in their own pure sense, I think that there is something more practical at play here. The importance of network visualization for database aesthetics. Summaries and statistics drawn from within the structure of the database are not enough. If there is to be any real grappling with the database in a culturally embedded construct, then it has to be done in a manner that reveals the data, the model, and the population simultaneously. Cymatics. Cymatics is the study of visual sound combined with vibration, a subset of modal phenomena. Typically, the surface of a plate, a diaphragm, or membrane is vibrated, and regions of maximum and minimum displacement are made visible in a thin coating of particles, paste or liquid. Different patterns emerge in the excitatory medium depending on the geometry of the plate and the driving frequency. The apparatus employed can be simple, an old Chinese spouting bowl or Chinese singing fountain, in which copper handles are rubbed and cause the copper bottom elements to vibrate. Other examples include the Cialdini plate and the cymoscope. The general term for this field of science is the study of modal phenomena, which was retitled cymatics by Hans Jenny, a Swiss medical doctor and a pioneer in this field. The word cymatics derives from the Greek kuma, meaning billow or wave, to describe the periodic effects that sound and vibration have on matter. Cymatics is a fascinating study for anyone interested in data visualization in the pursuit of visual sound. The apparatus used is fairly simple, usually involving a Cialdini plate, which is a flat brass plate excited by a violin bow. The results, however, are spectacularly complex. You might see images that mimic symmetries found in nature, like snowflakes or the rings of a tree trunk. It's a visual feast, it really is. You can get completely lost in it. There are a lot of parallel interpretations to cymatics. My favorite relates to crop circles or crop patterns. Examples in the use of mathematics and music include the stochastic music of Ines Xenakis, the counterpoint of Johann Sebastian Bach, the polyrhythmic structures as in Igor Stravinsky's The Rite of Spring, the metric modulation of Elliott Carter, and the permutation theory in serialism beginning with Arnold Schoenberg. Paul Adros expressed his views on the ineffability of mathematics when he said, "Why are numbers beautiful? It's like asking why is Beethoven's Ninth Symphony beautiful. If you don't see why, someone can't tell you. I know numbers are beautiful. If they aren't beautiful, really nothing is." The Emergence project was a software art installation at Hyde Park Art Center's Digital Facade Gallery that ran in the fall of 2008. The piece investigates how complex patterns arise out of a series of seemingly random simple interactions. These interactions were lifted from the actual moment-to-moment discourse happening at the Chicago Humanities Festival. The generative artwork simply uses morphological rules to animate word clusters based on linguistic proximity, similarities, and some differences. In the work, idea clusters embody contributions from panelists and the audience, captured by natural language processing software and the web. Thousands of local interactions between the creatures, as well as autonomous creations of new creatures, eventually generate patterns that represent the big ideas emerging from the discussions throughout the festival. The piece continues to evolve, giving us a visual of the evolution of these big ideas over time. Emergence has become one of the liveliest areas of research in philosophy and science. Examples of apparent emergent phenomena range from colonies of ants to the popularity of a particular hairstyle. Everyone ever in the world is a visual representation of the number of people to have lived versus the number killed in wars, massacres, and genocide during the recorded history of humankind. Existing paper area and paper laws represent the life and death, respectively. The total number of people who have lived was estimated through exponential regression calculations based on historical census data and known biological birth rates. If you have ever wondered how many human beings have ever lived during the recorded history of humankind, they can tell you. Approximately 77.6 billion. Those 77.6 billion people are represented on this poster as the total paper area. The total people killed in conflicts was collated from the number of historical sourcebooks. Approximately 960 million people have been killed, or roughly 1.25% of all the people to have ever lived. The time period measured begins in 3200 BCE and ends in 2009 CE, a period of over 5 millennia, chock full of conflicts, as we all know. Over 1,100 of them are visualized here. The sequence of dots to the top left of the graph shows the dramatic increase in the number of conflicts over the past 5 millennia, with the most recent 1,000 years being the most violent. The graph predicts a startling increase in the frequency of human conflicts over the next 1,000 years to come. The relative simplicity of using a die-cut area to represent total people killed lends poetry to the concept and affords the viewer an instantaneous assessment of the degree to which conflict has shaped human history.